Welcome everyone to the Accelerating Data Science using the Oracle Accelerated Data Science SDK session. I will be your host. My name is Jean-René Gauthier. I'm a product manager and a data scientist working on the OCI Oracle Cloud Infrastructure Data Science Service. And today I'm joined with my colleague, Nupur Chatterjee, who's a machine learning engineer, also working on the Oracle Cloud Infrastructure Data Science Service. So the safe harbor statement, I will be making some comments about our upcoming roadmap. So first, let me introduce the Accelerated Data Science. We often call it ADS SDK. So ADS is a Python library that was developed by Oracle, different teams at Oracle, that offers a series of tools and functionalities to cover the end-to-end lifecycle of machine learning models. ADS is offered as part of the OCI, Oracle Cloud Infrastructure Data Science Service, and it's currently available in the notebook session environment. And really the goal of ADS here is to make common data science tasks like doing data acquisition or exploratory data analysis, very common data transformation, feature engineering, model training, the standard model evaluation, comparison, and explanation, make those tasks faster, easier, and less error prone. And we've designed ADS for what we call the expert data scientist. I would say the expert is certainly going to get some benefit out of ADS, but also I think the beginner data scientist will also enjoy using ADS. But really, our user is a person who, or the typical ADS user would be someone who codes in Python. So it's perhaps not designed for what we call the citizen data scientist. It would prefer perhaps to use a GUI or a standard drag and drop interface to train their machine learning models. So it's really for the coders at heart. And there's really four guiding principles behind ADS. The first one being that ADS is unopinionated. As an SDK, you can use as much of it or as little of it as you want. And there's value in it at any given point in your workflow. So you can get in and out of ADS at any given point. The second principle is that it's agnostic. By agnostic here, I mean that it's not tied to a particular data source. And ADS provides different ways for you to connect to your data, whether the data is on Oracle Cloud Infrastructure, whether it's on-premise, or whether it's on other clouds like AWS or Azure. So this is interesting coming from Oracle. We're not tied to the database. We give you certainly the tools to connect to the database, but we are data source agnostic. Interoperability is perhaps one of the key aspects of ADS, and ADS is often best leveraged when you use multiple services on OCI, because ADS wraps the APIs of these services into a nice, easy to use Python module. So if you're using Dataflow, for example, the serverless Spark service, object storage, function, or even streaming, you'll get value in using ADS as well. But really here, the key is that ADS is easy to use. We made this interface intuitive, simple, and any method calls will actually do a lot in the background for you. So really the goal here is to shorten the time to put your models into production. And so this is a simplistic representation of the machine learning lifecycle if you want. So I put the different steps here at the top, data acquisition, data wrangling and feature creation, which is really the time when data scientists this is the step where data scientists are spending most of their time. You have model training, and then you have the steps of evaluating the models, explaining them as well, and then selecting them, perhaps a subset of the models for deployment, and then monitoring. And so on this flow here, I put also the key ADS primitives that you will see in our upcoming demo shortly. The two key primitives of ADS I've covered this sort of end-to-end lifecycle of the ADS dataset object and the ADS model object. And these key primitives unlock additional ADS functionalities that you will see also in the demo. And there's some around model training, including AutoML. So as part of ADS, we have an automated machine learning training engine that you will see, as well as AdTuner, which allows you to take any open source algorithms of your choice and then tune its hyperparameters efficiently. And post model training, the next step is typically the model evaluation, comparison, and then explanation to really understand the behavior of those models. And the key functionalities of ADS that you will see in the demo are around the ADS Evaluator object, as well as the ADS Explainer module. So now let me welcome my colleague Nupur Chatterjee, who's going to give you this first demo of ADS. So
yeah, thank you, JR. I'm going to start sharing my screen. And thank you everybody for joining us. I'm excited to show you a bit more about the Oracle Cloud Infrastructure data science ecosystem, and also walk you through an example Jupyter notebook that I've created, which will show you, as JR mentioned, the various ADS functionalities, including AdTuner, and also how AutoML and MLX can be used. So the service GA'd in February of 2020, and you can access the data science projects under this data and AI subsection. So when you open up into the list of projects, you will see, quickly refresh. You will see the list of projects that appears right here. And I have one set up for the demo already. So once inside a project, you can go ahead and create a notebook session, which will, once created, provide an interactive environment to put all your data science code. So creating a notebook session involves providing a name and then choosing a compute instance shape. And as you can see in this dropdown, we offer many VM shapes, including GPUs as well. So obviously, if the developer has a lot of data and therefore needs additional or more compute power, they would choose a larger shape and so forth. Next, they would pick the amount of block storage that they require. We offer anywhere between 50 GB to 1 TB. And currently work is underway to support up to 32 TB as well. And then the final step is to choose a VCN and subnet configuration. And the option to customize this basically means that attaching a VCN and subnet of your choice to the notebook can provide you access to the public internet from the notebook, and also access to different data sources. And our team provides some standard configurations or combinations that one can use if you're using this for the first time. So that's really useful as well. So once that is set up, you're ready to create your notebook session, and I have one prepared already. And as mentioned, this is basically the interactive environment where developers can put all their development code, all the way from feature engineering, model training, model evaluation, and model deployment as well. So when you enter this environment, the first thing you would navigate to is this Environment Explorer. And this is part of the Managed Machine Learning Environments feature. And as I scroll down, you'll see a bunch of these service-provided environments, each of which has been geared towards a different type of task. For example, we have one geared for data exploration and manipulation. We have one dedicated to ONNX-related work. We have one for machine learning as well. And in addition to installing one of these environments, which contains packages and libraries that will be useful for that particular task, it's also an option for the user to further customize their environment by installing any additional dependencies they might need to complete their task, for example. And I also want to draw your attention to, in this machine learning environment, for example, you will see we include ADS, Accelerated Data Science, AutoML, and MLX, which are 3 Oracle proprietary libraries. So ADS is built internally by the data science team, and it provides us with very short and powerful functions that give us snapshot views about the data set that we are using. And it also includes a bunch of very useful visualizations like precision recall curves, ROC curves, confusion matrices, and so forth. And then AutoML is used to tune a model class and therefore produce the best model. And it works on any supervised classification or regression task. And it does so, it works by essentially automating the three main steps in the machine learning pipeline, which would be feature selection, algorithm selection, and then hyperparameter tuning. And it does so with very minimal user interaction. And then finally, we have MLX, which is used to explain the behavior of models. Again, very crucial to the machine learning pipeline, and it's helpful for developers to understand why their model is behaving in a certain way, and also make sure that it's consistent with what they expect. So as you can imagine, it's useful for developers to have these environments set up because it makes it a more seamless process, and they don't have to go about installing and managing a plethora of different libraries that they would need. So I've already set up a machine learning environment for this demo, and now we will move into the example notebook. And as I mentioned, this is going to be a notebook that helps us to classify different types of Italian wine. So we start off by importing and loading all the necessary modules for our task. And the first step is to import our data set. As you can imagine, data comes in a variety of different file formats. In this case, in our case, our wine data set is in SQLite. SQLite is a fast and compact database, and we use the dataset factory.open method that uses a uniform resource identifier, or URI, to connect to the database. The dataset factory.open method, it also supports other common file formats, including CSV, TSV, JSON, and so forth. So in this case here, in this cell, we are importing our dataset. Once that's loaded, we can move on to conduct some exploratory data analysis and understand some of the underlying trends in the data. So here we're visualizing some of the rows. We can see that the data contains a mix of both continuous and categorical variables. And here we're looking at the show in notebook function. So I want to quickly draw your attention to this because this is a one-line powerful function, part of ADS. And it provides, as I said, a summary of things from the notebook. So it has simpler information like the number of rows and columns, but if you click through the tabs, you'll also see additional visualizations per feature. For example, this one is particularly interesting for us. Our target variable, which is the type of wine, it's been graphed here, and we can see that there's 3 unique values. So when we are predicting types of wine, we can expect to see class 1, class 0, or class 2. As I continue scrolling, you'll see additional visualizations per feature, all part of ADS. So once I get past this, and before we start training our model, we need to prepare our data set. And this section is so that we have a subset of the data which is used for our training and developing better models. And then we also have a subset that is unseen. So we call that our test data set, and we will save that for evaluating how well our model performs on data that it hasn't seen before. And again, we're doing this over here using the train test split function from ADS, and we're splitting using an 80-20 split. So we have 80% saved as our training data and 20% saved as our test data. So in this output here, you see we have 143 rows for training and the rest for test. So now once our train and test data sets are set, we move on to building our models. And we're going to build 3 models, which, as you will see, get incrementally better, if you will. So the first model that we're going to build is a linear classifier. And this uses stochastic gradient descent in its training. So following the API, you build the model, and you can immediately see how well it performs by outputting its score, which is the mean accuracy score. And you can see right here, it's about 48.5%. So not as good as we would hope for it to be. So we move on to building our second model. And in this case, to augment the performance, we're going to be using the ADS tuner. And as JR has mentioned, the ADS tuner is a hyperparameter optimization engine, which is provided as part of ADS. And it can be used to optimize any estimator object that follows the sklearn API. So again, we instantiate the tuner. We're going to be tuning the model that we just built in the first step. And we're using our training data. And once it's tuned, we can also assess the tuning process with the graphs, the plots, and the tables that the tuner provides. So right here, you can see the best scores over the many trials that the tuner ran. You can also see more details about each of the trials in this table provided. And finally, here you can see the output that the tuner has. So it's saying that building the model that we had with these particular alpha and penalty values will provide us with a better performing model. So now we train a second model using the output from the tuner, fit it on the training data, and voila, you can see that now we have a 60% score, mean accuracy score, which is better than the 48% we saw in the first step. So you also notice here that we have converted all our models to ADS models, and this allows us to use the serialization and estimation abilities further down in the notebook that you will see. It's also a good place to point out that the ADS tuner can be considered an alternative to AutoML because it specifically focuses on the end portion of the machine learning pipeline. So it's especially useful for developers who already know what features they want to be using, what algorithms they want to be using, and only want to be tuning the last hyperparameters. So that's where the ADS tuner is handy. Whereas AutoML, which is what we're going to be using to build our third model, will automatically do all those 3 steps for you. So again, following the steps to build an AutoML model, we go ahead and build it. And here you can see it gives us a accuracy score of 94%, which is the best model that we've built so far. So now that we have our 3 models, let's move on to evaluating and comparing them. And we do so with the ADS Evaluator object. And again, the visualizations that you see below are all part of this object, part of the show and notebook function associated with it. And lots of metrics here will highlight, and the green columns here will highlight that, in fact, the AutoML model was the best or the most, the best performing model that we built. And again, the normalized confusion matrix here, the strong green diagonal for the AutoML classifier, again, reaffirms that that in fact performed the best. So now with that, we will move on to, well, more metrics here. And then we move on to the last section, which is model explanations. And we're going to be focusing just on the AutoML model because that's the one that performed the best and would be the most likely one to move forward with in a machine learning setting. So MLX is used to conduct model explanations, and there's a lot of summary functions that provide background information into the calculations and how to interpret the visualizations as well. So let me scroll down to the first visualization. So here you can see the importances graph, if you will. And basically what this is showing is that according to this model and the data set that we provided to it, proline, alcohol content, and color intensity of wine was the most predictive of what type of wine it would be. And as we move further, we can look at some partial dependence plots. And in this case, we've chosen to showcase how the feature flavonoids would behave in the model if it was provided independently of all the other features. So again, the partial dependence plot, individual conditional expectation plots, all inform how the model as a whole functions, which are a form of global explanations. We also have local explanations, and apart from all the summary information that we provide as background, there is visualizations as well. And in this case, what we're seeing is how a particular sample was predicted and why it was predicted in that way by this model. So if I scroll further, you can see that this is telling you that, okay, the probability of this particular data point in the data set being of class 2 wine type is is higher because of the color intensity being above a certain threshold, the flavonoids being between these two numbers, and so forth. And it does so with the other possible classes as well. So that brings us to the end of the demo. Hopefully you got a good overview. And with that, I'm going to hand back to JR. Thank you.
Thank you, Nupur, for this great introduction. I really enjoyed it. Let me share my screen again. All right. So I wanted to go back on some of the key features that Nupur highlighted in her demo. So the first one is ADS dataset. So as you saw in the demo, we actually used the dataset factory object. We connected to a SQLite database to create an ADS dataset object. And what is quite remarkable with ADS dataset object is that you get a comprehensive data profiling method, the show in notebook that Nupur demonstrated, and you get a whole bunch of diagnostics with a simple method call. So what would take me as a data scientist, perhaps hundreds of lines of code to generate the same output with ADS, you can do it in a single line. We support at the moment, the ADS dataset supports tabular data format, but the roadmap includes support for also including text, images, as well as nested data structures. So we support a variety of well, ADS supports a variety of format, including CSV, TSV, Parquet, JSON, XML, Excel, and many others. But the backbone of ADS and the backbone of the ADS dataset object is Dask. And you can think of ADS datasets as being primarily Dask data frames. So any operations that you would normally perform on a Dask data frame can be applied to an ADS dataset object. And the key benefit of using Dask here is that ADS is essentially big data capable, because Dask can be used in a distributed fashion where the data can be split on different nodes on a cluster. And so at the moment, our notebook sessions are limited to a single VM worker. So you would do all of your interactive tasks on a single VM, but our roadmap calls to remove that limitation. Essentially, we want to give our users, our data scientists, the ability to leverage a Dask cluster that would be running alongside the notebook session, so that all of your interactive tasks like doing EDA, visualization, data prep, feature engineering would be done on the cluster itself. So you can do it on large amounts of data in a distributed fashion, so you would not be limited by the size of your notebook VM anymore. So as Nupur showed, ADS dataset has a very rich visualization API. So on the left here, I showed the show in notebook functionalities. For one of the particular features in the dataset, you can see here a breakdown of the counts, the number of rows in the dataset by, here's the job category from sales executives to manager to human resources. And on the right, the chart shows how you can leverage the plotting API of ADS. It's a very intuitive API where if you give it a column or two columns, ADS is going to find the best way to plot the relationship between those two columns. And so here in this case, I'm showing the count on the y-axis, and on the x-axis, I show breakdown by monthly income for different job types or job roles, if you want, from sales executives to research scientists to healthcare representative. So you can do that with a simple one-line command in ADS. So it's quite powerful. What I wanted to highlight next is how ADS dataset can actually recommend transformation for you to apply on your dataset. And there's a couple of ways you can approach this. We provide the get recommendation API as well as the auto transform one. So get recommendations will walk you through a simple GUI style interface, and ADS is going to walk you through all the columns in your dataset and recommends you to apply certain transformation. So if a column is constant, if a column, for example, has really high cardinality, if a column has a lot of missing values, for example, then ADS will recommend you to apply different transformations to that data set. And you can select, you can decide to apply the transformation or just skip it. The alternative to that is to use the auto transform API, which in this case is really a black box kind of tool. So ADS will apply all the transformation that it found the best for this data set without asking you if you consent on applying that transformation. So it's great if you want to do a quick run through a data set. As Nupur showed, we also support the AutoML training engine. And so AutoML actually covers all the 4 key steps you would expect to see in an AutoML engine, from algorithm selection to adaptive sampling. So you can think of adaptive sampling as selecting the proper number of rows in your data set. If you think of it as in a tabular format. Feature selection will target the columns in your data set. So how many columns you should put into your model. And then the last step is the hyperparameter tuning step, where for a particular algorithm that AutoML selected is going to try to find the optimal hyperparameters for that algorithm. And at the end of this pipeline, you get a tuned model for your data set. An alternative to using AutoML is, as Nupur mentioned, is AdTuner functionality, which is a hyperparameter optimization tool that is designed for open source libraries like scikit-learn, XGBoost, and LightGPM. So any object that follows the scikit-learn API could be optimized using the AdTuner. In the background, we're using AdTuner, which is one of the leading open source hyperparameter optimization framework. And we added on top of that a very rich visualization API. And we also allow you to examine all of the trials that you've run. And then we also allow you to, let's say, pause a tuning run and then resume it later, perhaps on a larger VM shape. So AdTuner, AutoML are 2 capabilities that you have to train models with ADS. But you don't have to use those tools. You can use your own. You can use an open source library if you want. You can use XGBoost. You can use scikit-learn. You can use TensorFlow, Keras, PyOD, LightGPM. And we give you here the ability to take that model, that open source model that you've created, and convert it into an ADS model. And the reason why you want to do that is because converting it to an ADS model object unlocks a whole bunch of capabilities, mostly around evaluation and explanation. Which I'm going to show in a second. But ADS model also allows you a convenient way to save your model. So once it's converted to a ADS model object, you can save the model. And the save operation will create a serialized version of your model. And we support the Onyx format as a first class format for ADS models. But as I said, a lot of the value in the ADS model resides in the evaluator and in the explainer API. So here I'm talking a little bit about the ADS evaluator object. With a simple command, show in notebook again, you can see a comprehensive series of diagnostics about your model, diagnostics and performance metrics. And we support regressions and classification use cases, whether they're binary or multinomial classification. And so you can select to see what diagnostics you want, or you can just select all of them. And same thing goes with performance metrics. So on the right here, I showed some diagrams of what a show in notebook method call would give you. So in this case, it's a binary classification use case. You see the lift, gain, precision, and recall curve, ROC curves. On the bottom, we're comparing 2 different models along different performance metrics for, I think in this case also, it's a binary classification use case. With a simple 1-line command, you can compare your models. And actually, we got the top vendor score in the recent model evaluation and interpretation category that was in the Forrester Wave Predictive Analytics and Machine Learning 2020 report. So we got a top score among all of the cloud vendors in this category. So now let me switch to, let me flip that coin if you want and talk about explanation, because providing a simple metric or just an ROC curve and selecting your model based on that is maybe not what you're looking for. You also want to understand how the model behaves. And this is really the goal of the ADS explainer object. It's to offer really a series of model agnostic, so it doesn't matter what model you use, explanation and interpretation that will foster trust in the results of your model, address a lot of regulatory needs that many industries have around eliminating bias in the model, being able to understand the model. And really the goal here is to increase the speed of machine learning adoption. And in the current ADS release, we support a variety of diagnostics. We have a global model agnostics, agnostic variable importance. So it doesn't matter. It's not just for trees, decision trees, or random forests. It's for any model that you have. We have PDPs, ICEs, and I think we have the first Python implementation of accumulated local effects as well. You can do local explanation, as Nupur showed. You can also use this tool we call What If, which allows you to change your feature vector and see the impact on the model predictions. We also support counterfactuals, and we have many more diagnostics in our pipeline. So I wanted to show you additional information. So if you want to learn more about ADS, please visit the ADS documentation. There's a lot of really cool examples in there to get you started with ADS. And please also feel free to watch our ADS intro video as well, available on YouTube. So I think right now we are ready for the Q&A portion. All right, so let me take on the first question here. So the first question is, what conda environments do you have? And there's a question on, do we have anything on NLP? So I think I'll take the first question, Nupur. We have a variety of condas. I believe in our initial release here, we have about 9 conda environments. So the use cases vary from, we have one on data exploration and manipulation. We have one on the Oracle database. I believe there's one on that targets more of a general use case for machine learning. We have one on Onyx. We have a PySpark conda environment, which allows you to do development work for PySpark and then submitting your Spark jobs to the OCI data flow service. And on GPUs, we also have a general machine learning for GPUs. So you have your standard, deep learning frameworks installed in that environment. And we also have the NVIDIA Rapids 0.16, so version 0.16 environment that is also available. We don't currently have a specific, an NLP specific conda environment for doing language work or natural language processing, but it's in our roadmap to actually build those environments for NLP, computer vision, things like that. The other question is, do we support images and text data in ADS? So not at the moment. We support tabular data, but it's in our roadmap to support unstructured and semi-structured data sets like text and images. So we have another question here on what's the difference between AutoML and AdTuner. So I believe that Nupur mentioned the difference a little bit in our demo, but I'll reiterate here what the difference is. So I think AutoML provides you sort of an entire step-by-step approach to AutoML. So from algorithm selection to adaptive sampling to feature selection and hyperparameter tuning. So all those steps are included in AutoML, but perhaps that's not what you want. Perhaps you already have an algorithm in mind and you've already selected the features that you want to have in your model, but you only need to tune the hyperparameters of your model. And perhaps your model is coming from an open source framework like scikit-learn or XGBoost. So here I really believe that you would want to use AdTuner, which really focus on the last step, which is the tuning of the hyperparameter. So really I would say if you have a model that's an open source model, and you only want to optimize the hyperparameters, I would go with AdTuner. Does AutoML support time series? Although, that's a good question. Although AutoML supports regression use cases, it doesn't yet support time series. We should expect to see this coming up pretty soon, though. It's a really high priority for the folks who are working on AutoML. So it's a roadmap item at this point. All right, any other questions? Why Dask and not Spark? Oh, that's a good question. So yeah, so Dask is often brought up in conversation as a competitor to Spark. So we picked Dask for a variety of reasons. I think one of the main ones is that it's a Python native framework, and it supports natively different machine learning libraries, including scikit-learn, and I believe also TensorFlow. So for distributed training tasks, it's a very convenient tool. Dask is also used as a backend for a lot of other libraries on GPUs, for example. So Rapids, I know Rapids and its different libraries uses Dask to also do distributed training workload, for example. So I think it was a natural choice for us as a Python library to use also a sort of a Python native tool. So so another question here. So you're showing me this demo on one node. How about large data sets? So yeah, so the notebook session actually runs on a single VM at the moment, but you can also use small or large VMs for your workload. So we support anything from running your workloads on a small, I think it's 1.0 CPU and 8 gigabytes of RAM, all the way up to 24 CPUs and I believe 320 gigs of RAM. So you have a range of VMs that could handle your workloads. You can also run your VMs on GPU shapes, and GPU shapes vary from one V100 V100 NVIDIA GPU all the way to 4 for larger workloads. And even if that doesn't fit your needs, you can also use the data flow service to process very large data sets. And in our roadmap for ADS and for the notebook session, we want to eventually be able to add this DAS cluster that could be running alongside your notebook session so that you can run your interactive tasks, your visualization, data preparation tasks on that large cluster that's running side by side. So this is not available right now, but it's certainly an important roadmap item for us. All right. I think I don't see any other questions, so I believe this is it. So thank you very much